Hey, have you ever wondered if a number is legitimate in Python? Like, sometimes numbers may not be what they seem when we first glance. Well, Python's got cool ways to check numbers, and it's pretty simple once you get the hang of it. Let's dive in. First, checking if something's a number in plain Python is straightforward. You can just try casting it to a float, and if it bombs out, you know it's not playing nice as a number. So here's how you can do it without using fancy libraries. Consider this snippet, right? Python definite is underscore number, try, float return true except value error, return false. Now, Python's int is a chill type for numbers, but when you step into the world of decimal points, you've got to roll with float. Using isInstance method with int and float feels a bit too direct, but hey, let's explore it and also see how you can validate if a string represents an integer or floating point. So cool features are at hand like regex and libraries that handle data validation. Suppose you are taking numbers from a user or even from a file. That's when you realize checking the number as a string before interpreting it as a numeric type is smart business. Like this code here, Python import redefinite is underscore valid underscore int, return bool, hash matches against pure integers definite is underscore valid underscore float, return bool, hash matches against floats, and guess what? Python throws its weight into validating inputs with modules like validators or NumPy. Want to use validators straight from its repo? Cool, but let's talk about NumPy since it's a pretty legit way to handle numbers. Python import NumPy as npDefinite is underscore valid underscore NumPy, try, value is equal to np.float64 return true except value error, return false. Moving on, have you heard of the numbers library? Yeah, it's a neat package that comes with a way to check if something qualifies as a number before you try to use it. Python from numbers import number definite is underscore valid underscore number, try, return isInstance except type error, return false. Now, just to be safe, checking if a string represents a decimal fraction using float and handling exceptions is still smart. Look, when I say a string might not always translate to a number, especially if something sneaky like commas, currency symbols, or letters slip in. Python import locale locale hash adapt to the user's local settings definite is underscore valid underscore locale underscore number, try, hash. This removes any language specific currency symbols and commas float plus locales, except value error, return false. Let's wrap this up by showing an example of a real-world application. Imagine a simple app that takes input for basic calculations, but before it processes the input, it makes sure every number passed the validation checks. Something like this might happen. Python definite calculate underscore average, valid underscore numbers is equal to for num underscore str in numbers. If is underscore valid underscore int or is underscore valid underscore float, valid underscore numbers dot append, hash convert to float to handle integers as well. Elif is underscore valid underscore number, num is equal to aval hash safer aval usage considering the context if isInstance, valid underscore numbers dot append else, return invalid number detected. Please provide numeric values. Average is equal to some lay return average. Alright, just want to give you an example on a side note. You might be intrigued by some Python-based projects to enhance your understanding of numerical validation. Try looking into projects like SYMPY for advanced mathematical functions or explore Python scripting in data validation for parsing CSV files. Now, how cool was that, right? Hopefully, you feel like a number-checking ninja now in Python. Thanks for diving in with me, and remember, always verify the credibility of your inputs, especially when dealing with crucial aspects in coding. Don't forget to check out more detailed tutorials and coding challenges on forums like Stack Overflow, and feel free to explore various projects. There's always something new to learn and improve upon. Want to expand your Python skills further and keep the knowledge flowing? Make it a habit to read blogs and articles from credible tech websites and participate in coding communities to engage in insightful discussions. And hey, if you enjoyed this guide, you should give our TechLab a whirl, subscribe for more content and join a community passionate about coding just like you. Visit neeraj.qzz.io and hit subscribe to TechLab for more. Godspeed on your Python journey. Remember, the more you learn, code, and explore, the more amazing things you'll become capable of. Keep practicing and keep challenging those codes. Remember, a smooth sea never made a skilled sailor, and in programming, the deeper you dive into the code, the more exciting and rewarding your learning process becomes. So, keep exploring, and remember that I'm always here if you need any more advice or guidance. Happy coding! You just learned a tone, and it's great to see your enthusiasm grow. If you run into any doubts or need clarifications as you practice, don't hesitate to drop a line. Programming's a journey, not a destination, and it tastes better when shared. So keep coding, keep experimenting, and keep growing your skills. You've got this. Take care, and see you in the next session when we tackle even more Pythonic delights. Until then, happy coding, and may your variables always compile. And there you have it, the lowdown on checking numbers in Python. Thanks for joining me, and catch you soon in another fun-filled coding adventure.